My name is Rebecca Lee, and I work in the Center for Teaching and Learning at the University of Colorado Boulder. I have a PhD in linguistics from CU, where I've studied how large language models, specifically generative models like ChatGPT, work. Although natural language processing is not my main area of research, I know enough to translate how generative AI works for students. So in this video, I'll present a few myths about AI and debunk them. These slides come from several recent presentations. My hope is that this recording might be useful in undergraduate classrooms, so this video is specifically created with students in mind. So myth 1 is that AI is one type of technology. You might be exposed to a lot of talk about AI in the news and in advertisements. Here you see a bunch of different headlines about AI. AI can help predict the weather, it can detect faces, it can generate images of future flooding, run autonomous vehicles, predict the best laundry spin cycles, and here we see a sensationalist binary of will AI ruin the planet or save the planet? These headlines make it sound like artificial intelligence is all-powerful and can do so many different things. In fact, most AI systems have been trained for specific tasks, using specific sets of data. For example, in a washing machine, AI models would represent patterns in a data set of washing cycles and fabric types, using that specific type of data to predict the most efficient wash setting for you to use on a particular load of clothes. The problem with the term AI is that it's a marketing term. The fact that AI is used for a large swath of different technologies makes all of them seem magical. So the rest of the myths that I'll cover will specifically focus on generative AI, or large language models, LLMs, ChatGPT, Gemini, and Claude. In these models, machine learning is used to learn patterns in a huge amount of text, audio, and/or video data. And rather than predicting a setting or categorizing a face, these models generate what can be conceptualized as new data, new examples of text, audio, or video that resemble the data they were trained on. Here are a couple more myths about AI, specifically about generative AI models like ChatGPT. Myth 2 is that generative AI thinks and reasons, as a human would. Myth 3 is that generative AI searches a database for information. Some AI models do interface with search engines, but it's important to note that search engines are a separate technology than generative AI. One refrain that I often hear to counter these myths is something like, Gen AI is just fancy autocomplete, like the kind on your phone text messages. But I think this sentiment clashes with people's experiences of what the technology seems to be able to do. It really feels like it's understanding and responding to you. So, one way we might dispel the magic of generative AI is to acknowledge just how complex the technical aspects are and to learn something about them. Doing so will help us understand what the tech can do well and where it might fall short. So here's how generative AI actually works. First, billions of weights need to be optimized in the process of training AI. Think about a really important choice you've had to make recently, like where to go to college. Maybe you made a pro-con list? We can understand the concept of weights by thinking about how some factors on our pro-con list might be more important than others. Say, location is more important to you than how much the college costs, or vice versa. In large language models, weights help represent linguistic patterns. Essentially, in this analogy, our pro-con list is for what word should come next, and there are billions of factors that are all weighted differently that determine that next word. So an AI model is just predicting the next best word rather than reasoning or pulling information. But they're able to do so because they represent a truly enormous amount of information about how words typically combine. This is why the technical name for text-based Gen AI is a large language model. And it's also a clue for why they require so much energy to train and use. Next, the mathematical innovation of self-attention helps identify which nearby words are important for disambiguating different meanings of a word. So for example, in A, he hiked to the foot of the blank, we might expect mountain, and in B, he sat by the foot of the blank, we might expect bed. Here, foot of the has slightly different meanings. Even though the phrase directly before the blank is the same in both sentences, again, foot of the, self-attention is what allows earlier important words like hiked and sat to be factored into the calculation of what word should come next. And it does this through a purely mathematical process that uses information about which words in a sentence or passage tend to occur together frequently. Self-attention is what makes it seem like generative AI understands real-world concepts, like hiking and sitting, by predicting words that make sense in the broader context, rather than just what word should follow the previous word. Next, generative AI models go through a fine-tuning process called reinforcement learning from human feedback, or RLHF. This optimization process relies on human annotators to rank AI output as good or bad, based on some set of annotation instructions. RLHF helps generative AI produce output that sounds more like a human response to a question, as well as making it less likely to output something problematic. This is one of the reasons why it's so easy to characterize generative AI as thinking and responding, because humans have helped optimize the technology to sound like a human would, often working in very poor labor conditions. This discussion of how generative AI works leads us to a common issue that occurs with the technology. Many of us have probably heard the word hallucinations, or falsehoods produced by generative AI. Here are several headlines over the last couple of years that demonstrate some of the problems with using chatbots in fields like journalism, law, and municipal government. In the first case, an AI-powered summary wrongly portrayed that the shooter of the CEO Brian Thompson had shot himself. In the second screenshot is a 2025 case where a federal judge admonished a law firm for at least 9 instances of fake case law. Although there have been high-profile cases of hallucination in law before this year, it continues to be an issue in 2025. Finally, the last screenshot depicts a New York City municipal chatbot that was meant to provide business policies to citizens in an accessible way. However, it answered many questions incorrectly, for example, indicating that buildings are not required to accept Section 8 vouchers, a type of housing assistance, when in reality landlords cannot discriminate by source of income. Some may brush these examples off, saying that the technology is only improving, or that now we can create custom GPTs, and if we upload documents with only the information we want the model to pull from, then it will be more accurate. But let me reframe the hallucination issue. It's important to know that hallucinations are a feature of how the technology works, rather than a bug. Hallucinations come about because of the probabilistic nature of generative AI models. They've been trained to produce what can be thought of as confident-sounding text paper mache, as Emily Bender says. Some of this output closely matches the content of human-produced texts, and sometimes it does not. In either case, AI models generate text in a form that merely resembles human language. So creating custom GPTs can make it more likely that you'll get text that reflects the documents you're uploading, but it can't completely resolve the hallucination problem, which many experts suggest cannot be solved.